Welcome back to 2 for 2 Math. I am your host, Raphael Thompson, and today we will be looking at another BGCSE mathematics topic, the topic on functions. So this is a topic that you may encounter on paper 3 of the BGCSE, and we will look at typical questions that they may give you, and I will show you how you can attack these questions. Get your pencil and paper ready. You can answer the questions at the beginning, and then we can look at your answers at the end. Number 1, the functions f and g are defined as follows. F of x is x cubed and g of x is 2 to the power of x. A, calculate the value of 1, f of 3, and 2, g of negative 4. Now I'm showing you how to work it. F of 3, where you see x for f of x, you put a 3 and work it out. And for g of negative 4, where you see x for g of x, you put negative 4 and work it out. And what you end up with would be the answer. So let's see if you can complete those two right away. F of 3, where you see x in f of x, you put a 3 and work it out. And then g to the negative 4. Let's move on to b. Dealing with the same functions, f of x, x cubed, and g of x is 2 to the power of x. Calculate the value of x for which f of x is equal to 729 and 2, g of x is equal to 64. Again, I'm going to help you. For b1, you write and then solve an equation with f of x, put it equal to 729 and then solve it. And then for 2, you write and then solve an equation with g of x equal to 64. So you write an equation with the numbers and work it out and see what you get. Please use your calculators if you need to. And we move on to number 2. The functions f, g, and h are defined as follows. F of x is x squared plus 1. G of x is 2 minus x. H of x is x plus 3 over 2. A, calculate the value of 1, f of negative 2. So again, substitute negative 2 in for x in f of x and then write what you end up with. And 2, gf of negative 5. Now for this, it's a composite function, so you do two workings. You put negative 5 for x in f of x, then put the answer for x in g of x, and then give a final answer. So that's a composite function. Number 2, gf of negative 5. So it's a little more working. Okay, and we move on to b, dealing with the same functions for number 2. For b, you have to calculate the value of x for which h of x is equal to 4. So they specified h of x, so go to h of x, and you write what you have there, x plus 3 over 2, and put that equal to 4. Solve it for x, and see what you get. So that's straightforward. Once you know your algebra, you should be okay with working functions because they deal with a lot of algebra. Okay, work it and see what you get. For 2b, you're only dealing with h of x. And we move along to 2c, dealing with the same three functions. Find in simplified form expressions for, and the first part, f, g of x. Again, a composite function. So you write an expression for g of x, and then you put that expression into f of x, and you simplify it and write the final answer as an expression. A lot of algebra. Two workings. So do g of x first, write the expression for that, and then put that into f of x and get an answer. Okay, this is C1, so you will have C2 coming up. And C2, it says find in simplified form expressions for, and this is 2, the inverse of the function h, or h to the negative 1. Same thing, inverse. Now here I show you how to work it. Right as y, where you have the function for h, you write y is equal to x plus 3 over 2, then make x the subject, and finally switch x for y in the answer, and that will be the inverse of that function. So I'm showing you what to do for the inverse. A little algebra involved, you should be able to handle that. And we move on to number 3. Given that f of x is equal to x minus 5 all over 2 and g of x is equal to 2x plus 1, find a g to the half and then b x where f of x is equal to 6. So work those two quickly. I already told you how to work examples like this. So where you have g to the half, you find the function that with g to x equal to 2x plus 1, and where you see x, you plug in a half and then work it and get an answer. And for b, x where f of x equal to 6, so find a function with f of x, x minus 5 over 2, put that equal to 6, solve it. In that one you would have to cross multiply and then work it out for x and solve for x. Work it quickly, see if you can get those two out of the way. Then we go on to c, same functions, find a simplified expression for f g of x. Again, a composite function, so you find and write an expression for g of x, 2x plus 1, and then you substitute that into f of x. So for x, you put 2x plus 1 into f of x, solve it, and you'd get an expression, simplified to get an expression when you put it into f of x, and that's it. A lot of algebra involved, but that's what you have to do. Work it quickly. Got it? And 3D, dealing with the same functions for number 3, f of x, x minus 5 over 2, and g of x, 2x plus 1. Find f to the negative 1, or the inverse of f. F to the negative 1 of x. So remember, for f of x, you put y is equal to x minus 5 over 2. And then you need to solve that for x. Solve that equation for x. And then at the end, you switch the x with the y. And that would be your inverse for f of x. Okay, test your algebra. And number 4, the functions a, b, and c are defined as follows. A of x is 4x, b of x is x plus 5, and c of x is x squared. A, calculate the value of b to the negative 4, and ab to the negative 2. So ab would be a composite function. B to the negative 4, just find b and stick in negative 4 for x, put a value. For 2, a2, you gotta work out b to the negative 2 first, get an answer, and then put that answer into a, the function with a, and get an answer. Work fast because you have to do a lot of working for a2. Okay, moving right along to 4b, same functions a, b, and c. Calculate the values of x for which bc of x is equal to b of x. So a composite function at the front, bc of x. So go to c of x and you get x squared. Then put that into b of x, where you see x, you put x squared. And then when you get that answer, you put that equal to b of x and work it to get the values for x. Got it? And we move on to 4c, dealing with the same functions, a, b, c. And c says simplify expressions for, this is the first part, a, c of x. So composite function again. So work out c of x, find c of x, that would be x squared, and put that into the function for a of x, and see what answer you will get. You'll get an expression. Okay, write that. Okay, composite functions are straightforward. Once you work one part, then you plug the answer into the next part, and then you're all set. And moving right along to 4C2 and dealing with the same functions a, b, and c again. Simplify expressions for the last part. The inverse of the function b, or b to the negative 1. Inverse of the function b, so find b, and where you have b of x, you put y is equal to x plus 5, and then I want you to solve that for x, and when you get to the end, change the x and the y, replace the y with x, and that will give you your answer for the inverse of the function b. And we move right along to number 5. The functions f and g defined by f of x is 2x plus 4. G of x is x over 2 plus 2. Find and simplify expressions for a, f to the negative 1, inverse of f. So work that first, remember. Find the function with f, and for f of x you put y. Y is equal to 2x plus 4. And I want you to switch that equation around to put x as the subject, and then switch the x with the y when you get your answer, and that would be your inverse. Got it? That's the first thing. 5b, find and simplify expressions for gf of x. So again, a composite function. So f of x, find f of x, which is 2x plus 4. Substitute that into g of x. The whole thing, 2x plus 4, where we see x, you plug that in for x and then work it. And whatever expression you simplify it down to, that would be your answer for gf of x. So a lot of algebra to do. Got it? Number 6, the functions f and g defined as f of x is 2x minus 3 and g of x is 4 minus x. A, calculate the value of g to the negative 3, and then b, calculate the value of x for which f of x is equal to 5. So work those two quickly. Calculate the value of g to the negative 3. So where you go to the function that says g of x, and where you see x, you substitute negative 3. Work it, get an answer. Then for b, go to the function for f of x and put it equal to 5. Solve it for x. Simple as that. Okay, the a and b, now you have c. Same functions for f and g. Write the counting numbers for which f of x is less than g of x. Write the counting numbers for which f of x is less than g of x. So put f of x to the front and put it is less than g of x and work it down, and then get your counting numbers for the answer. And that would be it. Okay, work it, see what you can get. And we are moving on to 6D. Same functions for f and g. Find g to the negative 1, the inverse of g. Remember what I told you? Let me repeat it again. For the inverse, where they have g of x, you replace it with y. So put y is equal to 4 minus x. When you get that equation, I want you to put x at the front. So I want you to switch it around, get x at the front. Then replace the x and the y, replace it with an x in the answer, and then that would be your inverse. That's all. So you must know how to find the inverse for a function. Got it? And we move on to 6e, same functions for f and g. Find and simplify an expression for f g of x. What is that? Yes, it's a composite function. So it means you have to do two things. First, find g of x, and g of x is 4 minus x. So where you see x in f of x, you put 4 minus x and work it out and simplify and get an expression, and that would be your answer. And we move on now. This one is a bit different. The function r is defined over the set and in brackets integers from 40 to 50 inclusive, as r gives you the remainder when x is divided by 7. That's important. So for the function r, it is the remainder when x is divided by 7. Calculate r to the 47 and then x, for which r of x is equal to 3. Remember, the integers for this are from 40 to 50, including 40 and 50. So do r47 first, plug in 47, and then do x, for which r of x is equal to 3. Remember, the answer is the remainder when x is divided by 7. And the last part of that, c, calculate x which have 0 as their solution. So same numbers, 40 to 50 inclusive, and you're dealing with the fact that it's the remainder. The function is the remainder when x is divided by 7. Calculate x which have 0 as their solution. And there are only two numbers that would fit that. I'm giving you a clue. Still dealing with a function. And here we go to number 8. The functions f and g defined by f of x is 2x minus 4 and g of x is x over 2 plus 3. Find g of 2. So go find the function for g and substitute 2 where you see x, get an answer. And b, simplify the expressions for, and this is the first part of b, 1 f to the negative 1, or the inverse of f. And again, let me repeat it. For f, the inverse of f, f to the negative 1, go to f of x and put y is equal to 2x minus 4. And then I want you to change the subject here, x to the front of that. And then when you get an answer, you switch the x with the y for the answer, and that's it. That's part 1. Now we get 8b, part 2. Simplify the expressions for gf of x, composite function. And again, I'll repeat what you have to do. So gf of x, find the expression for f of x, which is 2x minus 4. Put that whole thing in to g of x. Wherever you see x, you put 2x minus 4 and work it. You have to do a little bit of algebra, but that's what you have to do. And then simplify your answer, and you'd get an expression. Got it? Yeah, you should by now. You've had a couple of these composite functions. And we move right along on to number 9. The functions h and k are defined as h of x is 7 minus 2x, k of x is x plus 6. A, give the value of h of 3, and b, calculate the value of x for which k of x is equal to 5. So again, work the first part where h of 3, go to h of x, and where you see x, you put 3, and then work it. It's as easy as that, guys. And then for b, find k of x and put it equal to 5. So you see x plus 6 equal to 5. Solve it for x. And that would give you the answer for b. Got it? Good. And we move to 9c, dealing with the same functions h and k, and now we want k to the -1. What does that mean? Inverse of k. Do I have to repeat the process? I'll do it again for you. K to the -1, inverse of k, find k. So find k of x and put it equal to y. Y is equal to x plus 6. Solve it for x, and then at the end you switch the x with the y and write that as your answer. You have to remember to switch it at the end to get all of the points. And we move on to 9d, dealing with the same functions h and k. Find and simplify an expression for h of x. Composite function again, so find h, and the h of x is 7 minus 2x, so where you see x in h of x again, you substitute 7 minus 2x for x, and then work it, and then simplify that expression. For composite functions, you can have 2 or more functions, that's all it means, so don't let it scare you, just work it. Be two set of working for when you have 2 h of h, so you just do 2 set of workings and get an answer. And we move on to 9e, same functions h and x, and calculate the values for which h of x is less than or equal to k of x. So find h of x, 7 minus 2x, and put that less than or equal to k of x, which is x plus 6, work it and see what values you would get that would satisfy that inequality. And moving right along to number 10, the function h is defined as h of x gives you x plus 3 over 2, and a, calculate the value of 1, h of x when x is equal to -3, and 2, x when h of x is equal to 4. So again, h of x when x is equal to -3, go to h of x, where you see x, you substitute -3, work it out, and 2, x when h of x is equal to 4, so x plus 3 over 2 is equal to 4. Cross multiply, solve it for x, and that would be your answer for E2. You should get this by now. Coming up would be the answers, guys. But let's continue and do B. Function h is defined as h of x is x plus 3 over 2. Find h to the -1, or you want the inverse of h, and again I'll tell you what you do. For h of x, you replace that with y, so you see y is equal to x plus 3 over 2. Solve it. I want x to the front, and when you get x to the front, work it, and when you get it, an answer with x to the front, switch the x with the y, and then give me that as your answer for the inverse of h. Okay, the best part of it now is finding your answers and seeing what you were able to get correct. So here we go with number 1. F of 3 is 27, 3 to the power 3 is 27, and g to the -4 is 2 to the -4. 1 over 2 to the 4 is 1 over 16. Mark it right. If you got it, all you do is substitute the values in and work it. And we move on to B. And for f of x equal to 729, it means x cubed is 729. You can use a calculator for the cube root. That would be 9. And then for g of x equal to 64, 2 to the power is 64. Trial and error, work it out. So put 2, 2 to the 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6 would be the answer. So x is 6. 2 to the power 6 is 64, guys. Number 2, calculate the value of f to the negative 2. That worked out to be 5 when you substitute that into f of x. And g of x, negative 5. So you put f of negative 5 is 26. Put that answer into g of x and you get negative 24. Okay, so for composite functions, that's how you work it and get your answer. 2 set of workings, but you can get it done. And for 2b, calculate the value of x over h of x equal to 4. So put x plus 3 over 2 is equal to 4 and we'll solve it. X is equal to 5. Final answer. So a little algebra involved. When you cross multiply at the beginning, x plus 3 over 2 is equal to 4 over 1. Cross multiply, x plus 3 is equal to 8. That's what you did to get that. X is 8 minus 3. X is equal to 5. Straightforward. Some algebra involved, but you should be able to handle that. And move on to 2c. And you have another composite function, f g of x. So first you find g of x. G of x is 2 minus x. Substitute that whole thing into f of x. So you have 2 minus x squared plus 1. Work it, square it, and add 1. And you get x squared minus 4x plus 5. That's your final expression. Excellent work if you got that correct, guys. That was a lot of algebra involved there. And we move on to 2c. And you have to find the inverse of the function h to h to negative 1. So put y, and you put y over 1 is equal to x plus 3 over 2. And then you want x plus, cross multiply, x plus 3 is equal to 2y. So x equal to 2y minus 3. Replace the y with x. So h to negative 1 is equal to 2x minus 3. Not 2y minus 3 is 2x minus 3 would be your final answer because you have to replace the y with the x to get your answer for the inverse. And moving on to number 3, 3a. G to the half, put in a half where you see x. So you get 2 to the half is 1, 1 plus 1 is 2. And x when f of x equal to 6, put f of x equal to 6, cross multiply, x equal to 17. Okay, but you have to cross multiply first, x minus 5 is equal to 12. X equal to 12 plus 5, 17, guys. And we move on to 3c, a simplified expression for f g of x, again composite function. So g of x is 2x plus 1. Substitute that whole thing into f of x, where you see x, so put 2x plus 1 minus 5 over 2, and you get 2x minus 4 over 2, which gives you x minus 2. Final answer. And we move on to 3d, f to the negative 1 inverse. So again, go to f of x. Y is equal to x minus 5 over 2. And cross multiply, so you get x minus 5 is equal to 2y. X equal to 2y plus 5. And so you replace the y with x. F to the negative 1 of x is 2x plus 5. Final answer. Remember to replace the y with the x to give your final answer. Got it? Number 4, a, b to the negative 4. Just put in negative 4 where you see b of x. So it'll be negative 4 plus 5 is 1. And 2, a, b to the negative 2. So b to the negative 2 is 3. And then put that 3 into a. And you get 4 times 3, 12. 1 and 12. The answers for a, 1 and 2. Got it? And number 4, b, and we had to calculate the value for which bc of x equal to b of x. So work out the composite function first. So you get b, c of x is x squared, bx of x squared is x squared plus 5. We substitute put that equal, and then at the end we had to get x is equal to 0, x equal to 1. When you factorize x squared minus x equal to 0. And for c, you have to simplify an expression for ac of x. So you use composite function, c of x is x squared. Plug that into a, it'll be 4 times x squared, 4x squared. Simple as that. That would be your final answer for that composite function. And for c, same functions, a, b, c. Inverse of the function b. So again, b of x is x plus 5. So put y is equal to x plus 5. X x plus 5 is equal to y, x is equal to y minus 5. So b to the negative 1 inverse of b, replace the y with the x minus 5. Final answer. Got it? Number 5. So we had to simplify an expression for the inverse of f. Again, put y is equal to 2x plus 4. And then put 2x plus 4 is equal to y. So you want x is equal to y minus 4 over 2. Replace the y with your x. F to the negative 1, inverse of f, x minus 4 over 2. Be your final answer for that. And we move on to b. Gf of x, inverse function. So f of x is 2x plus 4. Put that whole thing in for x in g of x. So you get 2x plus 4 over 2 plus 2. And when you work it, you get 2x plus 4 plus 4 over 2. 2x plus 8 over 2, which simplifies to x plus 4 when you divide by 2. Got it? Yeah. And 6. We have to calculate the value of g to the negative 3. Put in negative 3 into g of x, and you get 4 minus 3, which is 4 plus 3 is 7. And then value of x, fx equal to 5. So put 2x minus 3 is equal to 5. Work it down, you get 2x equal to 8. So x is equal to 4. And we move on to 6c. Write the counting numbers for which f of x is less than g of x. So put 2x minus 3 is less than 4 minus x. Work that down, put x's to the front, numbers to the back. So you get x is less than 2 1/3. So if we want the counting numbers, it would only be 1 and 2. So the counting numbers for the answer if x is less than 2 1/3 would be 2 and 1. And 6d, g to the negative 1, inverse of g. Again, y is equal to 4 minus x in g of x. So 4 minus x is y. So x work out to be 4 minus y. Replace the y with an x. So g to the negative 1, inverse of g is 4 minus x. When you replace the y with the x, you have to remember to do that at the end. And 6e, and you want fg of x, composite function. G of x is 4 minus x. Put that whole thing into f of x for x. So you get 2 times 4 minus x minus 3. So you get 8 minus 2x minus 3. And that simplifies to give you 5 minus 2x. Final answer, guys. Got it? Good. Now we move on to 7. Now here you had a, you had to put r of 47 into it. So when you put 47, divide 47 by 7, you get 6 remainder 5. So r of 47, the answer is 5. You're only dealing with the remainder. And then x, for which r of x equal to 3. So that means the number divided by 7 is x remainder 3. And remember the numbers are from 40 to 50. So 7 times 6 is 42. 42 plus 3 is 45. So x is 45. And then c, x, which have 0 as their solution. Remember, we're dealing with numbers from 40 to 50. 7, 6 is a 42, so that'll be remainder 0, 42. And 7, 7 is a 49, that's how the remainder 0. So the answer for x, with 0 as the solution, is 42 and 49. And we move on to number 8. And we have to find g of 2. And g of 2 worked out to be 4 when you substitute 2 in for x and g of x. And then simplify the expression for f to the negative 1 inverse of f. So put y is equal to 2x minus 4. Put 2x minus 4 to the front is equal to y. Finally, x would be y plus 4 over 2. Replace the y with the x. So f to the minus 1 is x plus 4 over 2. Final answer. And 8b, simplify expression for gf of x, composite function. F of x is 2x minus 4. Put that whole thing into g of x where you see x. So you get 2x minus 4 over 2 plus 3. So you get 2x minus 4 plus 6 over 2 when you work it as a fraction. And then you get 2x plus 2 over 2. Divide by 2, you get x plus 1. And 9a, give the value of h of 3. So where you see x and h of x, you put 3, you would get 1. And then the value of x, for which k of x is 5. So that means x plus 6 equal to 5. Work it. X equal to 5 minus x. So you get negative 1. Straightforward. Just put your values in, find the function, put your values into that function, write an answer. No mistakes there. And 9c, you want the inverse of k. So find k of x and put y is equal to x plus 6. X plus 6 is y. X is equal to y minus 6. Replace the y with the x. So you get x minus 6 would be the inverse of k for the function k. Remember to replace the y with the x in the final answer to get full marks. And 9d, find the simplified expression for h of x. So composite function h of x is 7 minus 2x. Plug that into h of x again. So where you see x, you put 7 minus 2x. So you get 7 minus 2 in bracket 7 minus 2x. 7 minus 14 plus 4x. So you get 4x minus 7 when you simplify that expression. And 9e, calculate the values for which h of x is less than or equal to k of x. So put 7 minus 2x less than or equal to x plus 6. X is to the front, you get minus 3x is less than or equal to negative 1. So x, you switch it around because you're dividing by a negative. X is greater than or equal to negative 1 over negative 3, which is 1 over 3. X is greater than or equal to 1/3. Final answer. And number 10, the final one. A, calculate the value of h of x when x is negative 3. So put negative 3 into it, and you get 0. Negative 3 plus 3 is 0 over 2. So it's 0. And then x when h of x equal to 4. So put x plus 3 over 2 is equal to 4. And solve, cross multiply. You get x plus 3 is equal to 8. X equal to 8 minus 3. X equal to 5. And 10b. You want h to the negative 1 inverse of h. And again, for h of x, you put y. Y is equal to x plus 3 over 2. Cross multiply. X plus 3 is equal to 2y. X equal to 2y minus 3. Replace the y with the x, and you get 2x minus 3 for the inverse of h. H to the negative 1 is the inverse of h. 2x minus 3. Final answer. Got it, guys? Thank you for watching, and hope you understand how to deal with functions now. Remember, you have to just plug your values in, and when you have the inverse, you know what you have to do. When you have composite functions, you should know what you have to do. Okay, but that's all I can show you for functions, and if you need to, just look over the video again. Thank you all for watching. God bless you. Share me out. That's a wrap.